Thank you very much. So my name is Matt Stephenson. I'm a software engineer on the Google App Engine team. My notes aren't showing up. And so this is a talk about what is expected of a platform as a service in 2013. So first off, what is a platform as a service? There's a lot of different terminology that's used commonly in the industry right now. You have services as a service, platforms as a service, and infrastructure as a service. Going down the stack, you kind of start off with services as a service, and at Google we have several. We have Gmail, we have the Google Calendar, Google Drive. Microsoft has Office 365. There's Box.net that has their own service as a service. And there's just a whole plethora of these across the industry. Generally, these are different services that are consumable by individuals or by users. It's something you can sell. It's something that someone can take advantage of. And it's just kind of like to put a data point on all of this. Talk really isn't centered around that, but there's a lot of really great APIs out there that are services as a service. There's APIs that are offered from all sorts of companies like Twitter. The Google Drive itself, which is a service as a service, has an API that's really fun to hack with and build on top of. So this is more of just a data point for you, but that's something to really explore on your own. Platform as a service is really the interconnectivity between all of the points that are in the service as a service bucket, and anything, and how to get those services running. So at Google we have Google App Engine, we have Google, we have BigQuery, we have Google Cloud SQL. There's several other platforms as a service out there in the industry, like Red Hat's OpenShift, which allows you to run all sorts of different runtimes on top of OpenStack and a couple other infrastructures. CloudBees is a really good example, which is a platform as a service that's built on top of Jenkins. And so there's a whole lot of innovation happening in this space, and there's a lot available in this space right now in the overall industry. And what we're kind of coming to with all of this, and I'll move on to infrastructure as a service. Now we're looking for infrastructure as a service as all of the ways that you can actually run things, run your code, like where you're going to run it and how you're going to run it. So Google Compute Engine provides compute facilities. Google Storage Engine provides a way to store data. OpenStack is a project, an open source project that has compute and storage facilities within it. And Rackspace also has compute and storage facilities. And just kind of to build on this, all of these different components at each level have APIs that are exposed that you can consume and you can use as a developer. They're really powerful, and more we're seeing a giant ecosystem building up around all of this and building up to be able to be used in the long run. So let me see if I can, okay, let's see. So moving on real quick, let's take a look at some examples of what a platform as a service has generally. So generally a platform as a service has some kind of data storage mechanism. So let's take a look at that real quick. Let's see if I can get this to work out all right. Okay. So let's take a look here. I've got a couple applications running in Google App Engine. And so we can take a look at the JFocus lab we ran earlier today, as long as, there we go. And so in Google App Engine, you have a data store that's provided for you with a really simple, easy API. A lot of other platforms as a service offer data stores, and you can always kind of roll your own. So, for example, you could easily put together your own platform as a service that utilizes Cassandra, like the Airlift project that I'm a contributor to. So if you were to take a look at this, at the Airlift project on GitHub, you could see that we actually built a Cassandra integration to provide a data store. But in Google App Engine, this is just kind of an example. You can see that we've built a NoSQL data store on top of Google App Engine. And here you can see we're actually persisting various entities to support the lab that we ran earlier this week. The data store has a whole lot of facilities that you'll find in a NoSQL provider like Cassandra, like indexes. This application hasn't been really running long enough for the viewer to work, but for the statistics to really work. But there's a lot of information you can get out of a platform as a service provider like Google App Engine that will that'll make it easy for you to put data back in the back end of your application. So, what's going on here? Sorry. Okay. Wait a minute. Just a second. Okay. All right. So, what else do you have in a common platform as a service? So I talked about data storage. We also have a caching facility within Google App Engine, and many platforms as a service have caching facilities. So if you take a look, we have some information statistics on the actual memcache here. Oh, sorry about that. So we have some statistics here on our memcache provider, and you can actually kind of see, if you look in the lab that we did earlier today, which I can just pull up, it's pretty easy to integrate with it. I'm just going to go ahead and take a look at the commit that we did for that lab. I believe that was step 8. And yeah, so you can actually see that really simply we can get a hold of a cache service from within the platform itself and do some increments. We also have some data store code in this lab that we build up, but the actual cache itself, the memcache itself, is incredibly simple to use. So finally, the last, or not the last, but next up is user identification. So in Google and in Twitter and Facebook, you have kind of like the concept of a user. You also have things like OpenID. And in order to really take advantage of having users of your service, you want to also be able to authenticate and authorize them for certain levels of access. With Google App Engine, that's really easy. It's also really easy if you're using authentication through Facebook's OAuth integration or Twitter's OAuth integration. And just as a sample of that, we do that as well in the lab. Here on, I believe it's actually really easy, really early on in the lab. Well, I would suggest taking the lab for that one. Anyways, the actual integration for it, the actual looking up users and such, is really, really simple. User service is very easy to use. Some of the things that you don't normally think about, monitoring. App Engine has some very advanced monitoring that you can take advantage of on your application. There's also support for monitoring in other platforms as a service like OpenShift and such. Automatic scaling, so the ability to scale is incredibly important. I don't think that I'm working too well on this one. And probably my favorite topic is scaling. Something that people argue whether it belongs here or elsewhere on the platform. Arguably, you can do things like monitor raw network traffic and do this in your infrastructure. But I've tried that myself, actually, and it's not So great. Scaling is something that you really need to think about from the perspective of the platform, since the platform can ultimately be leveraged to make more educated decisions on how to scale. So for example, I can do things like say, from the platform's perspective, the platform generally is going to be where you're actually handling, so in a traditional platform as a service, you're going to be handling your actual HTTP requests there and working with them. So you're able to do a lot more analysis on how many requests a given instance is processing, and you're capable of making decisions like, I'm seeing that I've just ramped up by 10-fold in the last millisecond. I know that I'm going to need 10 times the machines that I currently have. App Engine takes care of a lot of that for you, but there's also a lot of systems out there that are working to help with that, one of which is Scalar, I think. It's a pretty neat project. And I think that that's actually what they're primarily about. And of course, you can certainly try to roll your own automatic scaling. This is one of the things I think that Google App Engine just really is one of the best platforms out there for. It takes care of that for yourself, and it's certainly a hard problem, and Google's been doing it for a long time. So, I skipped one over. Communication APIs is another thing that we support, which is pretty neat. We have the ability to do emails out to users, and we have XMPP support, and a couple other things. Amazon has something similar to this as well. So all of this is kind of pulled together into the platform. And the thing that really makes platforms difficult to implement, in my experience, after having worked on some of the components of Amazon's platform and in my past, and also on several other open source projects that are platforms as a service, and now in Google App Engine, is the language bindings. So, I mean, App Engine supports Java, it supports Python, it supports Go. So it's very difficult to get language bindings right, and I'm really happy that with App Engine, it's pretty clean. Okay, so all that said, I've been saying a lot of great things about Google, but sometimes you don't really want to just use one player in the field. So now this new kind of kid on the block is showing up in the last year or so called the hybrid cloud. And there's some really great projects emerging like jclouds and fog and libcloud. They're allowing you to write your own, they're allowing you to utilize their abstraction layers to build into your platform as a service the ability to not necessarily just use Google's infrastructure or just use HP Cloud's infrastructure or Rackspace's infrastructure, but you have the ability to quickly change the cloud to whatever you like. It's easy to write something that makes it difficult to take advantage of different cloud providers without some kind of testing and such. So I would advise always testing out your code. But there are some standards being worked on that'll make it a lot easier. Using something like jclouds or fog or libcloud, you have available a new set of APIs to code against, instead of the traditional vendor-specific APIs that you might have used in the past. This allows you to write some pretty neat, simple code that provides you with nearly the same functionality as the code you might write to a vendor-specific API. So actually, we can actually. I got that next slide. The awesome bit about the whole hybrid cloud thing that I like is that it's putting an impetus on cloud providers to expose more of their SDKs into the open source world, including Google. Since joining the team there, I've personally been working on making it easier to contribute and work on our SDK. So trying to make that more open and more available for all of you to be able to improve it, as well as have a good channel into us to make it better. I'm happy to say that actually all of our samples are now going up to GitHub, and the lab that we ran earlier, as you can see, it's currently sitting on my GitHub, but I'm going to fork that back up into the Google GitHub so you easily be able to see the lab that we ran earlier here at jclouds, or at JFocus, I'm sorry. And I would strongly suggest watching our repos for some more updates. There's some really cool stuff that we're going to push out there, and I would just hang tight and see what comes out. So one big reason that you might want to do this hybrid cloud approach is like, why have one infrastructure as a service when you can have them all? It's surprisingly a growing concept regardless of the complexity, and as a committer on jclouds, I'm pretty happy with that. You have the ability now to use Google or Amazon or to allocate overflow instances, and you can still pretty easily host your own cloud locally using OpenStack. It allows you to also attempt to allocate resources based on pricing and region. And previously, in a previous life, I was responsible for building a hybrid cloud, and it was a pretty fun experience. It was complicated, but totally feasible using existing technology. There's a bit of code I had to write. We can actually look at that here in a moment. We built a cloud there that utilized a project called Airlift, which I mentioned earlier, which is a platform as a service. jclouds was what we used to do provisioning, and Airship we used to deploy artifacts, and we provisioned on top of AWS, HP Cloud, and OpenStack all at the same time. A lot of that is done to support the growing need for having a physical ownership of your actual infrastructure. And so I can kind of step you through a few things here now. So looking at jclouds, actually using jclouds to do that provisioning is really, really, really simple. So instead of doing your traditional, using traditional APIs from... Oh, is it not rendering properly? So instead of using like the traditional SDKs that are delivered by different infrastructure providers, you can pretty easily use jclouds to abstract away those vendor-specific object models, and all of a sudden you have the ability to kind of be a lot more portable in what you're working with. So right here what I'm showing you is how you can get a hold of the context to utilize a compute service for a specific compute provider. In this case, this is the Terramark provider, which I believe is a provider that's built on top of, it's a infrastructure as a service provider. It's kind of a smaller company that provides the vCloud Director APIs. So it's kind of based on the VMware APIs. But as you can see, you're not writing anything here that's VMware specific. You can easily list the nodes that you have currently. Creating nodes is pretty easy. We can take a look at that real quick. Let's go to the bottom there. And, oh, that's right. I had this pulled up in IntelliJ, so it's a little bit cleaner. Let's see, is that showing up all the way? Yeah, okay. So if you look here, this is actually just a really simple connector into that's completely cloud agnostic. We're right here, we're just building up a context to be able to work with various underlying cloud providers. And then a little bit later on, we actually are able to, oh, here, this is an interesting bit of code. I forgot to highlight this. This is actually, even though you're working with a cloud agnostic API, you're working with like a object model that's not specific to a specific cloud. You do have the ability to always hook in and make certain decisions based on if someone chooses a specific cloud that doesn't support something, or the support might not be that great. Like EC2, in this case, EC2 has so many instances that you can't possibly list them all, or images, you can't possibly list them all. Right here, this right here, the template builder, is pretty much how you construct what an instance is going to look like when you instantiate it. And then a little bit later on down here, using the create nodes and group, we actually create those instances. So you can see there's no real vendor-specific anything here. There's a little bit of work here to try and deal with some AWS specifics, but this code was easily used to run on AWS, HP Cloud, and OpenStack. So as you see, there's nothing specific to OpenStack or HP Cloud in there. Okay, so moving along. So really a big motivator for this is compliance. And it makes it a lot simpler to deal with situations where, in that specific case, we had to actually have physical access to the hardware. So having a private cloud and a very specific location made it very easy to be able to deploy into that. And actually, one more thing here. I can actually show you real quickly how to get your own private cloud started up. Now, if you try to do this here, if everyone tried to do this here, that would probably just kill the network. There's actually a project that would probably just kill the network. There's actually a project called devstack.org that we use to do testing, which will actually get you up and running really quickly on your own machine with an OpenStack instance. And I actually did that right before the talk here, and I've got an OpenStack running on my machine here, on my laptop. Go on ahead and just launch instances. Oh, I have to name it. And I need to select an image. Okay, so it's building. And there you can see it's been allocated resources. It's active, it's running. And that really is just running in a VirtualBox instance right here. It's just running away. So as you can see, it's pretty simple to get a hybrid cloud up and running, and it makes it really easy to do development locally as well as running up in something like App Engine. So what matters the most in 2013? Well, there's a lot of really great features and a lot of really great stuff going on in this space, and there's been a lot of innovation over the last few years, but sadly, the thing that matters the most is not the fun parts, it's the parts like people getting hacked. And it's the parts like reliability. And we aren't immune to that, unfortunately. So looking into that a little bit, there is some support in App Engine to make it easy to deal with denial of service attacks. And we have our own system status up here. AWS has something similar. Several cloud providers do. And many of these have simple APIs that you can use to determine if your service is up and down as well. Plus all of the monitoring that's built into these providers today makes it a lot easier to do, very easy to do that. As you can see on the 26th here, we really didn't have that. All that was out was the runtimes. And we had a bit of a blip here, but we recovered pretty quickly. Most days it looks about like that. All right, so that's the bad news. So when you also want to kind of think about what we've been doing in the along the realm of evolution. The scale that we're working at is evolving. We've gone from like single racks, single data centers to, as you can see there on the left, or on your right, on your left. That's what a Google rack used to look like. And now, on the right, that's what data centers look like now. And it's not too uncommon for any of the major tech companies to have a data center like on that scale. So the scale that we're working at is evolving. We're using more and more resources. We're getting into situations where the resource economy is becoming very problematic in some ways. Amazon AWS has the spot instances where you can actually bid on instances and be able to get auctioned off instances instead of having to pay full price for them. And if you watch the spot instance market, you'll actually see some fluctuation in it recently that's kind of interesting, where you'll see the price jump up above the standard pricing. The other thing that's evolving is user experience. There's a lot of work right now in the JavaScript world around supporting new ways to provide experience to users through projects like AngularJS, Backbone.js, Node.js. There's a lot of work in HTML5. A lot of these frameworks take advantage of WebSockets and more advanced communication mechanisms, which is becoming a really important factor for platforms as a service, and certainly something that's going to be be added into existing platforms as a service is 2013, as far as I can see in my crystal ball. And the other thing that's evolving is automation. We're getting lazier about things, which is actually really good. We have a lot of real great facilities to do builds and deployment. Jenkins and CloudBees are just like amazing for doing continuous integration. And of course, Chef and Puppet are just excellent for being able to push bits to the box. So I guess that really comes down to what is expected. So simplicity is expected in user experiences, which is going to make the entire, all of the necessity for us to build up good support for underlying JavaScript or user experience libraries. Performance is becoming a really important factor because of the resource economy constraints and the ability to scale. At Google, it's kind of fun to think about how many instances we have, but it's not really the massive amount of machines that helps any big platform company like Google or even Facebook. What really helps is the ability to have a high-performance auto-scaling capacity, so the ability to go from 10 to 1,000 to however many instances you really need. And then, as well as performance, one of the other big things that's becoming important today is choice. So the ability to use something like jclouds or Fog or libcloud to make choices and be able to choose different clouds that you can use. And then finally, I think the most important point is reliability. So having the ability to use Compute Engine or Storage Engine or OpenStack or Rackspace or GoGrid or AWS, all of these just all the different choices you have and how reliable each one of those choices is really, really important. Let's see. I had a few other things to demo here, so let's take a look here at a few other things. We have one of the other nice things that platforms as a services are providing today is a lot of billing information, billing settings, billing history. And that's making it a lot easier for you to understand how much you're spending on clouds. That is actually one of the downfalls of using something like jclouds or Fog today. So if you're using jclouds or Fog, it's very difficult to determine at any given point in time how much an instance might cost. There's not really a good abstraction for that yet, so I think that contributions into that is really important. I think that as other platforms evolve, it's going to be very important to have those platforms be able to support billing information. And I guess I can actually do a few more demos. I can also talk about a few more specific points. Does anyone have any questions right now? Okay. So back to we're looking about user experiences evolving. Supporting some of these new forms of user experience. A very important thing that's being worked on right now is Google Cloud Endpoints. It's currently in trusted tester for App Engine, and so there's a lot of frameworks like this that are being developed that makes it really easy to have a single API provided with your business logic running inside of your platform, and you provide like a very simple API specification, and then you can generate bindings both for Android, iOS, or for HTML5 or JavaScript to be able to talk back to your actual endpoint that's being exposed. And there's a whole lot of facilities evolving to do this. So that's something that's pretty neat. That's definitely going to be evolving over the next year. Yeah, let's see. Some other things that are kind of catching up. See if I have anything else in my notes here. Oh, geez, that's not working now. Okay. So yeah, I think probably auto-scaling's going to be one of the biggest ones. Anyways, I guess that was a little bit quick. No questions? All right. Well, I guess that's it.